Welcome, everybody. Good to have everyone back here. We are excited to get going in just a few minutes. I see people are filling into the room. It's good to have everyone here in this fine May evening. I assume it's fine everywhere in the world, no bad weather anywhere, but I know in the New York area, it is good weather, so everyone is enjoying that. So it's right before we get started, we'll do our normal announcements. And we just have the normal stuff. First thing is jobs. If you are looking to hire someone or you're looking to get hired, you should go to the job postings channel of the NYHackR Slack. Go there, post the jobs that you are looking for. In fact, someone just a few hours ago asked me about announcing jobs. And since we're not in person, it's kind of hard to announce jobs. Go to the job postings channel and you'll find jobs there. I think that'll be really good for everyone because everyone likes getting jobs and everyone likes hiring people. So it's a win-win for everybody. Personally, since I am on screen, I am hiring for my company, Lander Analytics. We're looking for sales. We're looking for Linux developers and engineers. We're looking for Shiny developers. So please go to landeranalytics.com/careers and find a job there if you're looking for one. Then, as per our usual, pizza. So I got my pizza over here. I burned it. I reheated it incorrectly. I made a mistake. I burned it a little bit. But this was a beautiful looking slice before I got to it. You can see the bake on the bottom. It had good cheese like the slice I had earlier. And since I reheated it, things went a little astray. That's from a place called Antonio's. But let me know where you folks have food from. Let me know where you're coming from. It's always fun to see where different people are coming from, but also what you're eating. Like everyone knows, I'm obsessed with pizza. This one's from Antonio's. And hopefully you folks all have good pizza or other food. We are very excited about the next 2 months. This month's speaker was our very first virtual speaker. He's spoken at other events we've had, our conferences, our meetups, but in April 2020, as we all were in lockdown, Noam came on and was our very first virtual speaker. And if all things go well, he will also be, almost exactly 2 years later, our last only virtual speaker. Because starting next month, we are going back to a hybrid model, in person and virtual. Exact details are going to come soon, but we're going to have the in-person component somewhere in New York City and the virtual component on Zoom. So if you're coming from far away, like coming with your teriyaki chicken from Boston, you'll still be able to join us with the chat feature enabled. We'll have Zoom and in person. So next month, June 2nd, will be David Robinson. He'll be in person. We'll have the details announced in the next couple of days. And it'll be a great time, and we'll do both in-person and virtual. For those of you there, you'll be able to eat pizza with us all together. Those of you not there, you can have whatever food you want from far away. I'm really looking forward to that. There is going to be a rule from the venue that everyone must be vaccinated to get in. So you're going to need to show proof of vaccine, either your vaccine card or you might need to register with the company. We'll have details a little bit. You might need to be registered in advance of this company system. Details will be coming, but you need to be vaccinated to get into this building. We are very excited about that. So more details are coming. And remember, it will continue to be hybrid, virtual, and in person. And David Robinson, our June 2nd speaker. Remember that, folks, mark your calendar, June 2nd, starting roughly around 6:30. I think the talk will actually begin right at 7, but we'll come up with details. He's going to be our speaker, and he's also going to be the bartender for the New York R conference coming up a week later. June 8th through 10th is the New York R conference, our first one back in person and virtual. You can do either one. It's going to be a really fun time. We have some great speakers, Jennifer Hill, Max Kuhn, who will be another bartender in addition to David Robinson, Andrew Gelman, Bernardo Lares, Iggy Skokin, Megan Robertson, Tom Bliss, a lot of really fun speakers. There's going to be workshops on June 8th. You could take a machine learning workshop. You could take a causal inference workshop, a Shiny workshop, or even a Python for our users workshop. It's going to be all sorts of good stuff. To learn more, you can go to rstats.ai to check it out. you can get a 30% discount using code NYHackR30. Just for members that are here tonight, we want to welcome you as members of this community. Again, go to rstats.ai and use code NYHackR30 because this conference is really meant to be like a 3-day R meetup. And remember, R and friends. This whole meetup has been for over a decade, R and friends. So we really like to see a good turnout. Another thing, we have No Starch Press offering the meetup group a 25% discount on all of their items until June 5th. And you can use code IRNY22, all capital letters, IRNY22. That'll get you 25% off of No Starch Press. So that's pretty awesome. So remember, folks, June 2nd, David Robinson will be our first in-person speaker in 2 years, and it'll be both in-person and virtual. June 8th through 10th will be the New York R conference, and you can get a 30% discount with NYHackR30 if you go to rstats.ai. To check out all past talks of this meetup, you can go to nyhackr.org. No Starch Press is giving us 25% discount with code IRNY22. Sorry about that, folks. If you're looking to hire or get hired, go to the job postings channel of the meetup and enjoy your pizza or other food. With that, I'd like to say we've come full circle. Hopefully, we'll see, as long as everything's going according to plan. Our very first fully virtual speaker, and hopefully our very last for a while, fully virtual speaker. I'd like to everyone give a warm welcome to Noam, who's not only spoke twice during this pandemic, but has also been providing the Zoom link for us this entire pandemic. And we all know how crucial that is. He's a repeat meetup speaker, repeat conference speaker, and an excellent biker. So everyone, please welcome Noam with a virtual golf clap, and I'll do one audibly if everyone could do it in the chat.
Thank you very much, Jared. Good to be here again. Now, I guess it's been my fifth or something like that talk between the R meetup and the R conference, 5th or 6th or 7th, and it's always a great group to talk to. And looking at the attendees, it's fun that there's new people and a bunch of people I know from the New York R meetup, but actually a bunch of other communities we work with elsewhere, R Open Sci and others. So today I'm going to talk about data versioning for reproducibility with R and Dolt, a potentially very dry subject. Last time I did this, when it was April and we were in a lockdown, it was on coronavirus research, and I think we had the large. I don't think we've ever had as big a virtual audience as then. But I'm glad to be able to be talking about dry topics rather than emergency topics. Before I dive in, let me tell you a bit about myself. So I sort of come to the R meetup from perspective of 2 different organizations. So my background is actually as a disease ecologist. I work in computational disease research, disease discovery and forecasting. I work at an organization called EcoHealth Alliance. EcoHealth Alliance is based right here in New York City. We're an international nonprofit focused on wildlife conservation and human health, doing both research and advocacy at those places where people are interacting with wildlife and forests and gaining the understanding and communicating and education to help both protect people from diseases that can spill over from wildlife and protect wildlife from the diseases and other consequences of human encroachment into wildlife habitat. I also wear another hat at an organization called R Open Sci. R Open Sci is an open source nonprofit developer collective, we like to call it. It's an organization that's focused on improving the interoperability of data, the openness of science, the ability to advance science through open source data and code. And we do a lot of activities in the R ecosystem, ranging from peer review of R packages, establishing standards for evaluating statistical algorithm, doing community outreach to improve the accessibility and diversity of the R developer ecosystem, and sort of doing testing of new tools that we think will be interesting for reproducibility, such as containerization, new tools for things like versioning. And so what I'm going to talk about today is something that's both sort of in the tool set of what I use for computational research and this sort of frontier scanning that we do with our OpenSci. So the plan for today is to talk a little bit with some background on sort of versioning data in general, why we do it, what some options there are for doing it, what sort of the types of tools you might use and the reasons you might use them in a broad way, what we've looked at in other places in our OpenSci. And then I'm going to jump into an introduction to a tool called Dolt that I and my team have been working with for a few months, which I'll describe as a Git-like SQL database, and I'll talk about what that means a little bit. I'm not a developer of Dolt itself. I'm a new user. We have some of the developers here, but it's a tool that I've been experimenting with, and I have an agenda with everybody here in using this because I am interested in seeing the R community also try it out, because I want us to kick the tires to see whether it's a good tool for us to work with. And the Dolt's team, which is very communicative and very responsive to their users, will put more effort into our users if more our users try it out. And so I'm hoping that some of that two-way communication can come out of this. I'm going to introduce you to Dolt R, which is what I've been working on, which is an R client for the Dolt database. I'm going to live demo something. I have been working on it up till about 65 minutes ago. So, we'll see how that live demo goes. I've just punched in a new feature in the last hour. I'll show you around with that. And then I'm going to talk about some workflows that you could use it for and the workflows that we're trying out right now at EcoHealth Alliance. Then I'll talk about things that I'm developing, that Dolt is developing, and for Q&A, we'll be joined by Jason and Zach, who are in the audience, and for your questions and our questions for each other. So the first thing to think about is why we would version control data at all, why we would think about it. It's sort of something that is sort of an intuitive idea for people who are like really deep into reproducibility in a certain type of development, but trying to understand what's the purpose of version control data helps us understand what kind of tools we might want for it. And then for most people, it's like not the part of the system they work with at all. And so if you're version controlling data, you want to make sure that it works for those who don't care. But I mean, the fundamental problem is that a lot of data is live. We work with data streams that come in that represent the state of a system, that represent new data gathered. It's the new clicks at a website or the new swipes. In my case, it's new data coming in from the field, from veterinary monitoring, from scientists who are collecting new data. And so new information comes in, and that tracks often real processes in life. And it changes over time. And sometimes data changes in predictable ways. So you can add more records, you have expectations, people will change fields in the back end of an app or something like that. But just as often, you have all sorts of other strange mutations and changes to not just the data, but the structure of the data, the metadata in the database, because things go through revision and curation. The schema of your data changes, meaning sort of like what the columns in your tables are and the relations to each other, because you have changing goals. A database can be designed for one purpose and changed to another. You can design it for one purpose and discover you need something else. Often there are sort of quality assurance and quality control processes that cause you to go back and need a lot of revisions. One example I think of on that front is we have databases full of collections from animals, and those animals have names. And as biological research continues, the names of species change. So you might have a bunch of categories of animals, and we're going to go back and change the name of everything that used to be called Pteropus giganteus, which is the flying fox, is now Pteropus medius. So it's not like we've collected a bunch of different species. We have to go back and change the archival data again. So it's not something so simple as, oh, we've added new records. We have to go back and do wholesale modifications, and that's going to change our processes down. And yet, in the face of all of these changes, we need to be reproducible and auditable. If I do an analysis and publish it in a scientific forum, I need to make that analysis reproducible in such a way that can trace it back to the original data that it came from. But if we're connecting to a database that's undergoing revisions like this, there needs to be some way to control for those constant changes and have a record of what the state of the data was at the point where we did our statistical analysis or our machine learning. And so that's the use case that I think about a lot. It's not the only one. Another big one is on the challenge of collaboration in your database development and curation. So you might be building a database for a specific purpose, be it that you're building the structure of a database because it's the back end of some interface or some app, or you might be trying to assemble a lot of data. A bunch of work that we do ends up being sort of harvesting records from different sort of historical, scientific archives, databases, and literature and putting things together. And that often involves a team of people getting together and all submitting records, but even as they submit records, finding new types of records we have to capture, new types of data we have to capture. And so they have to be able to collaborate in this elaborate, often nonlinear way to have all that information put together. And for all these reasons, we need some kind of mechanism to trace our steps and build a database incrementally. So those of us who have been involved in a process like this probably at some point have ended up doing the approach of using Git. Git is the tool that probably the bulk of us here use to version code. Most of us are familiar with Git and GitHub, and Git is a very effective version control and collaboration system for code, or fundamentally groups of files organized in folders that the files themselves are organized as lines of text. When the information you have is organized that way, Git is designed essentially to help you version control it. And there are probably cases where using Git to store your data is not a bad idea. If you're doing something where you have an analysis and a set of data, in a lot of cases, you would sometimes want to keep those coupled together for purposes, maybe just sort of like the data creation and the analysis are really one unit, and you can put that in the same point. Sometimes that's bad. There's a lot of cases where you want to decouple your data processes and your code processes, and you don't want things in the same Git repository, let alone another Git repository. This approach is very inefficient for a lot of data. So because fundamentally Git is organized around code and lines of text, and data isn't necessarily organized in that way, sort of physically or conceptually. Data, if you have square data like tables and CSVs, then your changes are not necessarily 2 rows, but they could be 2 columns. Lots of data is in different structures, such as JSON files that aren't necessarily versioned well on that front. So fundamentally, it's sort of a mismatch, especially when it comes to efficiency, and also it's not really aware of those data structures that are there. On the other hand, there are definitely tools that help you do this. It's definitely a solution for certain cases. At our OpenSci, we do this peer review of code, and one of the packages that went through that is something called Get to Our Data that specifically works on saving data into formats that are maximally compatible with Git structures. So, for instance, the same data could mean different things in different order while it's different orders, but Git would not see it that way. So Get to Our Data maintains data ordering and does a number of other things to try to make Git as efficient as it can be. And so that's one tool, if you're using something like this, you can use. And then if you're an R user, a number of other packages that are designed for sort of understanding differences across data object. Diffobj is a general package by Brody Gazlam for comparing different versions of R objects you might have stored. DAF is specific to our data frame. So here on the right is sort of the kind of thing you can compare different data frames in R and get like differences between them. And so this is something that can be used, and I've definitely used it within certain limitations. So I gave you an example of when we were trying to pull together information from different archives. We have a big study we did a few years ago that was sort of a machine learning approach to understanding the viruses that could be in certain different types of mammal species, and it required really diving into long historical archives and literature to understand what people had found in various expeditions over the years. And that was something where we built a database collaboratively with a bunch of people through Git and GitHub. You know, these CSV files have long commit logs where we're like, oh, we gotta fix this reference, we gotta change this. So it turns out that this was in the wild and not a domestic animal. So we have lots of commit logs like this and changes like this. But fundamentally, one of the challenges here is what you're doing is you're versioning the data format. You're versioning the file. You're not versioning the data itself that it's representing. And when your data are in this form, it's not preserving the data types. It's not preserving the interrelationships that more rich database technologies can give you. Then there's this whole other class of versioning approaches that I'm calling here versioning in a build system. So there are a number of different tools that our users, and especially people who are building machine learning pipelines of various sorts, might use that are fundamentally build systems that are around tracking the different objects required to produce a final output. So these are often directed acyclic graph setups, essentially, that take in the combination of your code and your data and run everything through a series of steps. And often what they're doing is they're building efficiency around the caching of the intermediate objects that you build. So the R package targets is probably the latest and greatest package in the R ecosystem specifically for this. And it has versioning capability. So it doesn't just cache the objects that you store, but it has the capability to do versioning around those objects that you store, essentially, so you can back up to a previous version of your code and a previous version of your objects and run again. And underneath it, it can use Git. It can also use the Amazon S3 storage system and its versioning approaches to do things as well. Outside of the R ecosystem, there are more general tools. There's one called DVC, which means data version control, that sort of fundamentally uses this approach. And there's another one called Pachyderm that does something similar. It's also built around containerizing each of your machine learning steps. So it's this sort of like tightly coupled data versioning, data pipelining, build system approach. But this is generally not data aware at all. So what happens across most of these tools is that any input, like a file of data, be it a Parquet file or a CSV file or a connection to a database that you are inputting, is just stored as a binary blob, an object. It's nothing more than its like version, its timestamp, a hash file of the whole thing. And those are stored in some kind of key value table so that the system can look them up and you can back up to a different version. But the system is not really aware of anything underneath it. And that's good on one hand, because it means that you can throw any data object or a file at it. Usually it's file-based. On the other hand, it doesn't have all of these things that we're accustomed to in Git, such as forking and branching and having a collaborative workflow that lets you fork and experiment, essentially, and then modify the data itself through those tools. And then you have databases that have versioning awareness built into them. And there's sort of a couple of classes of these. One of them are traditional databases of the sort like Postgres and MySQL, or even the simplest ones such as SQLite, DuckDB, which is really popular in our ecosystem at the moment. And what you can do with those is create database structures internal to them that put versioning as part of the record. So Postgres and MySQL have a feature called Temporal Tables, and it's basically, if you have a table of data, you create a side table of data, and in that side table of data, it has a record of, this is the version of that record in the other table, this is when it started being valid, this is when it ended being valid. And in a certain situations, when you have like a really, tightly controlled fixed data schema, right, that you know what you're setting up, and you know that like the temporal table that you might attach to it, those are pretty useful. But they themselves are not sort of versioned databases. So when it comes to version databases, there's two that I know of that are sort of databases of the sort like your Postgres's or your MySQL's, but also your NoSQL databases like MongoDB. The first is called Terminusdb, and Terminusdb is a graph database. So it's much more like a MongoDB, sort of a document-based store, and it has Git-like versioning. And then there's the one that I'm going to dive into a little more, which is Dolt. And so Dolt has Git-like versioning, but it itself is an SQL or relational database of the sort that many of us are familiar with, such as Postgres or MySQL or SQLite, or even some of the things that which are bigger systems like Google BigQuery. So let me give you Dolt in a little bit of a nutshell. It's a relational database or an SQL database. So a lot of us are familiar with that as a database source. It has Git-like versioning. Dolt itself is a single binary program. So it's a program that you can download, you can run on your machine, you can run on a server. It's written in Go. It's compiled into a single object, and that's often very useful. It's much easier to manage and install than some other things like MySQL or Postgres, which has sort of many more sort of system components that you have to deal with. Dolt stores all of its data on disk in sort of a version backend structure, which is called Noam, so that's not really important. And then the interface to Dolt is basically a drop-in compatible version with MySQL. And MySQL has a drop-in compatible version called MariaDB that's more open source in its licensing than MySQL. So MySQL, Maria, and Dolt are all compatible in interface. I'm going to pull a Hadley here and edit my slide as I present it. And then Dolt itself, you can work with in the command line, or you can work with in a server client interface as you would connect to any other database connection sort of in our ecosystem. So what do I mean when Dolt is Git-like and has Git-like versioning? What are the sort of properties that make Git what it is that Dolt absorbs? So the first is sort of the general day-to-day workflow of it. So you've got, you can make a change to the database, you can add or stage that change, then you can commit that change, and that sort of creates a fixed point within your database. And then from those fixed points, you can branch, you can create multiple branches, you can look at differences between those branches or between different steps, and you can merge them together. Like Git, it has a push-pull workflow where one can have a local copy of the database. There can be a remote copy of the database in another location, and you can push up and pull down. And this is not necessarily centralized. One can have multiple remotes. One can push the database to different places, but it's often in one sort of like big central hub where most of it comes. And then at that hub, there's sort of you can send patches or do a pull request approach. So people who are working on different versions of the database can send changes to each other across repositories that are not necessarily the same ones. Dolt has a web interface, much like Git has GitHub. Dolt is run by a company called Dolt Hub that manages that hub called Dolt Hub, and also has something called Dolt Lab, which is a self-hosted version of that. Dolt Hub is that central hosting service for Dolt repositories. It can be a place where you push your data to, you serve your data, you distribute your data to others. It serves that data via sort of the Dolt interface, but also can serve it via an API or sort of via straight data exports. It has some limited web-based editing capabilities. And as I said, you can have a self-hosted version of it in addition to a version that's hosted in the cloud by Dolt Hub itself. So I think before I get through too many bullets, what I just do is show you what Dolt Hub is from sort of the perspective of a user. Dolt Hub is really, it's a cousin to in the best way of knock off of GitHub, in that it's fundamentally organized the same way. You have a repository for your database as opposed to your code base. And within that repository, you have a front page with a README, a database page that shows you all of the tables in that database, a commit log of the changes in that database. You can have tags or releases, issues where someone files an issue associated with your database, pull requests for modifications of that database as well. When you're in a Dolt Hub database, you can view any of the tables, which is essentially doing a query at the top of that table, and then any table that you have, you can look at it in any point in the history, the changes that occur in the database in the history, and then you can export a query via a API call. You can also export it just as query results as raw CSVs, or a whole table as raw CSVs. This thing, the CSV part, I think is really essential, because it makes it so if you are a Dolt user and you are push and pulling to Dolt, that doesn't mean that a non-Dolt user doesn't have access to your data. If you push things up there, anybody who is interested in your data can get it via the CSV export links, and as opposed to trying to run Dolt and clone it themselves. That said, you can have other Dolt users who are using it because they want to patch or contribute or otherwise use your data in a database form. So you can get an export of any table you're viewing. You can also get an export at any commit in your table's history, or any branch, or the tip of any branch that you're working on. So you can jump to a different branch, and then you can export from that branch or that branch's history as well. A couple of notes before I dive into the R side and sort of give a live demo of how this works, about what Dolt is not. And maybe the developers will contradict me in this and they'll have different opinions on it. But one of the things is Dolt is not, is it's probably not your fastest option for data import or export. So a lot of the R ecosystem often is interested in the shootouts between the Feather and Parquet and Arrow, and the speed of the various sort of CSV imports. DuckDB is this super high performance light database that we've been using a lot in the R ecosystem. Dolt isn't going necessarily to win in those competitions because it has a performance overhead associated with all of that versioning. In my experience, those aren't where my biggest bottlenecks are, but since Dolt is built off of these traditional SQL databases, sort of an organization like MySQL, it's row-based as opposed to column-based. And so In recent years, column-based has become really interesting for people who are doing machine learning and big analytics, because often what you're doing is fetching the entirety of one big column, because then you're doing a computation on that, as opposed to filtering to some small subset of rows. So there are limitations on that side, not limitations that have been a problem for me. And similarly, it's not a big data product in the sense that it's not fundamentally something like Spark or otherwise that's designed to work with data across a big distributed cloud, because you have enormous amounts of data that you are querying down that don't fit on a single server. It's a product database. It has a lot of capacity, has a lot of speed, but it's not that. It's also not like your critical system database yet. I know that Dolt's backend is being rewritten quite a bit at the moment. It's still, I think, would be described as a beta product, though increasingly parts of it are stabilizing. I know that Dolt, the company, just recently switched to using Dolt itself as their own backend for their own databases. So as they were building it up, they had a different database, I think a Postgres database that ran their systems. Now a Dolt database actually runs the systems that build and run Dolt themselves. But there are things changing, and changing very rapidly within the system. So it's more a place for looking at your next approach, your next production system, than like your stable critical system right now. So how does an R user get into this or use this in a reasonable way? So I've put together a package called Dolt R, and we're going to jump into demoing that in a moment. And so Dolt R is 4 things currently at once, because Dolt itself is multifaceted. And so Dolt R has to sort of draw from different approaches in order to deal with it. So in the R ecosystem, there's a thing called DBI, the database interface, and it's the common approach for database interfaces into R. So Dolt R is a DBI style wrapper for the Dolt database. It lets you interface with the Dolt database the way you would with those other databases. It's also a manager for the Dolt server. So Dolt is this single binary that can run on your computer or a server. If you are running it on your own computer for the purposes of working on a database locally, Dolt R can take care of that part for you. It starts it, it stops it, it deals with it all in the background, so you never really have to deal with the server process. Then Dolt R has an API for the version control parts of Dolt. So R has 2 main packages that people use for working directly with the Git library for purposes of managing version control. One is called Girt by Jeroen Ooms, part of the R.Sci group. One is Git2R. They're very similar. They have some slight differences in terms of like performance and stability on certain sides, but they cover the same thing. So they have a sort of a standard interface, and Dolt tries to imitate that interface for versioning in general. So you can work with versioning in a way that feels a lot like Git, much like the Dolt's command line interface feels a lot like Git. And then finally, Dolt R is an Rstudio plugin, so you can handle a lot of these things and get a lot of information from the graphical user interface as well as the R console. I think the best way to actually explain all of this is to give you a demo as to Dolt R, which will give you an introduction and understanding of the database itself. So this script, which I just finished writing, I will push up and have in a repository for people to use. It's also pretty much based on the vignette that I've written for the Dolt R package, which is available at this and will be on my slides and along with the talk materials and the talk video when we post those later. So Dolt R package is something we load as anything else. And then we might want to work with a database that exists. So before I showed you on Dolt Hub a database repository. This one is one I've made specifically for demonstration, and it's the New York City flight data, which many people are familiar with because it's a big example data set that's used for dplyr and dplyr database interfaces. So if we run Dolt clone, it will pull that repository from Dolt Hub. Here, of course, Dolt Hub is the default remote for that package, so you don't have to put the whole URL, but ultimately you could change the remote that you are pointing to. And when you do that, it's going to create a directory here called NYC flights, which is your Dolt repository. Inside that, there is a README that's associated with the Dolt repository. There's also the .dolt, the hidden directory. That's where sort of all the binary structures, as well as configuration of the database live. What I've done in Dolt R is create the concept of a default database. So the challenge is that both Git, which is probably how you've organized your project directory, and Dolt have the same idea that they work within a working directory on your machine. And you're not going to be in two working directories at once. But in my experience, for most projects, you have the project code directory, which is what Rstudio is in right now, which is this Rstudio project. And then you have the main database you're working with, or I think it was default database. So the way this is set up is if you set an environment variable, in this case, setting it as Dolt directory is NYC flights, that will be the default directory. And when you run Dolt commands in Dolt R, it'll always point to that database. I find that a pretty convenient way to set this up. I'd be interested in feedback on that approach. If I set that environment variable, then this command, which is just Dolt, will always be a connection to that database. And the idea behind Dolt is it's the shortest and simplest command to handle a whole lot of things at once. When you run this command, it finds that directory. If there needs to be a database server to serve that directory, it will find the Dolt binary. It will start a server. It will keep it running in the background. It will reconnect to it if it needs it. If that server crashes or halts, it will restart it. Ultimately, the idea is that you don't have to deal with the server processes very much at all. So if you run Dolt, it gives you a connection. In this case, the connection has a nice print method down here, which tells you this is a Dolt connection on my local machine. It's called NYC flights. It's being served out of this directory, and the server process is this PID. We're connected to it via this connection. We're on a branch. There's a last commit that was made, and our working database is clean. Just like in Git, you have no changes to your database. So your working directory is clean. Here, your working database is clean. The Dolt has a remote, so you can list your Dolt remotes. It'll give you a tibble of the name of your remote and where it's pointing to. And with that, you can interface with this like any other SQL database you work with in R. So if you load the DBI database for database methods, you can list your tables in Dolt. You can read a table in Dolt. So here we can read this airlines table. And if you want to, you can use the dplyr interface that many of us are used to, and its sort of domain-specific language for working with data to work with this database as well. So if you load dplyr and the database pyr backend, you can define a tibble that is from this database that calls flights, and you can do your filtering or your modification and ultimately collect the output in sort of a standard pipeline. And finally, you can use your DBI package to modify the database. You can add a table to this database. So when you modify it, you start getting into that sort of versioning space. And all of these Dolt underscore functions deal with that. So we've modified this database. We can look at what the status is. You're on Dolt status. You're going to get the current status of your database. This says you're on a working branch of your database. There's a new table called empty cars. This prints nicely, but it actually is printing a comes out as a data frame. So you can deal with that status and manipulate it and work with it because it comes out as data itself. So it's a data frame of what's the table has changed, is it staged into the repository, what's its current status. Most of these commands also pull out the versioning information as data. So you can run Dolt log, and that'll give you the history of commits from your database on a current branch. Each of those commits, as you might be familiar from Git, has a hash. You can say, see who committed it, what's their email, when that commit happened, and what the commit message is. And if you want to work from data anywhere in that history, you can check out commits with Dolt use. So this is the equivalent of an SQL use command, which would be go to a specific database. In this case, it means go to a specific commit. So this changes our Dolt status, and that is reflected when we print the database. Now it says using a fixed read-only database at this commit. So this is the equivalent of being in what you'd call a detached head state or something like that in Git. You're going back to a commit, so you're not going to make changes to that there. You're in a read-only mode, but you could do a checkout and launch a new branch from here, for instance. You can go back to head with a simple Dolt use that brings us back to our main branch, and we have all of our tables, including the one that we had just added. You can also make use of this as of syntax. This as of syntax is something that's built into Dolt's SQL syntax, which I'll point to in a bit. But as of can take either a commit hash or a date. So you can ask, what's the status of, give me the flight table, read it out as it was as of this date or as of a commit. Or we can now take that and make the changes that we want. So we already did this. We already put this new table in. If I do Dolt add empty cars, it's now no longer in the working set, but it is a staged table. If you look that once again as data, it's the same as it was before. We have the table. In this case, it is staged. And then we can commit. In this case, you can commit your repository and commit to your repository with a message. But I'll skip that because we also have a setup that if you don't create a message and you're in an interactive session, you'll be prompted for one. So this works in Rstudio. It also works outside of Rstudio. If you're in the command line it'll ask for a message. So we are adding the empty cars table. Now we have a clean status, and you can grab the last commit. And finally, you can push that to Dolt Hub. And if we go to our Dolt Hub repository, commit log, this needs to refresh. We've just added a table to our database, and that can be viewed as a diff in our data, which tells us what's changed here. And you can see not only that we've added data, but we have changed the schema of the database by adding this new table to it. So this essentially is the summary of the minimum SQL code required to modify the database in order to get that change. Now, this is all in the command line, and many of us are rather in the R line, and many of us work there. But one of the really neat things about Rstudio is that it has this, pretty functional Git client right here, which lets you do your staging of your files and your commits and see your history all through here. So I wanted to see if we could get a similar set of capabilities in Rstudio, because I learned to do Git in this pane before I learned it in the command line. It sort of got me where I needed to be for that. So I thought for someone to learn how to use Dolt, they want to be able to learn the concepts without necessarily having to learn all of the syntax. So if I run Dolt Pane, we fire up an Rstudio connections pane for the database. Now, you may be familiar with the Rstudio connections pane. It lets you connect to any number of different databases, have them connect to them directly, view the tables. But this one has some tweaks to it that are specific to Dolt. So first of all, the pane will always give you the current status of the database itself up here at the top. So you've got your main branch, you've got your last commit, and that your working database is clean. You've got where that database is stored, or if you're connecting it remotely, what the URL you're connecting to remotely is. And then you can browse your database as you would other SQL databases. So you can look at the schema of any table or get a preview of any table up here. But what we have in addition to your core data is your Dolt system tables. And your Dolt system tables are where all of the versioning information that you can use to manipulate your database are stored. So there is a table of your different branches of your database. There is a table of your documents. So there's a table of the README or the license files is stored as another table. You have your commit log. And then every table itself that you have in your database also has a diff table and a history table. So your history table gives you, it's sort of like a blame view. It gives you the commit hash and the committer and date that are responsible for every row in your database. So you can look, this is a row in my airlines database. It was created in this hash created by me, and other rows were committed at other hashes. And this goes through all of the history. So even if the same row is repeatedly added, you see which commits. So you can pull this and you can filter it to find where in history certain records came from, what history you want to back up to. There is also a diff table for everyone, and that has columns that are to and from every record you have in the table, and it'll tell you what the change was between this commit and this commit in the history of your table. So you can filter by the commits and get the differences you want. And so this was the state of the database before, which did not have this table. And then this commit changed this from being a blank because there was an absence of values in that table to having these values for carrier and name. So this is a useful table for querying and interrogating the history of your Dolt database. Also within this pane, we have just some buttons that imitate the same buttons you have in your Git pane here. So for instance, if I were to, let's see, make a modification here. So let's add more information to the empty cars table, right? This pane updates, and now this was the last commit, but the working state of the database is the empty cars table has been modified. So you can stage those changes, and that's staged, or you can unstage them back to your working state. If you stage, you can commit, and as before, add more data to empty cars and make a commit to this. And you can push that to your Dolt Hub remote, and that sends it to your remote. Finally, there's a log, and that just pulls your Dolt log history out as well. That's the same as the Dolt history table, the Dolt log table down here. And the other thing that I want to make sure that's important to note is that there are good ways in and out of the database itself and the Dolt ecosystem. So I'm not necessarily going to use Dolt with certain collaborators that aren't using it. And so you want to make sure that things are possible for them to do. So, you could just read data straight from Dolt Hub. Dolt Hub has a CSV export for every databases, every table at every commit. So I could read CSVs from 2 different commits in a database, and then use a different set of tools like DAF to look at the differences between those versions. DAF has this nice HTML widget that shows you changes in a table. Or if you're working with the data locally, you can get it into a different format for other work. So the Dolt dump function will export into CSV, JSON. We'll do a full SQL dump that's capable for migrating to another database, and also will export Parquet files. So I can run Dolt dump, and all of my tables are here in Parquet, ready for whatever wants to slurp those up. There's one sort of thing that I note as I work on this in terms of how people use SQL databases. There's 2 main uses I tend to see in the R ecosystem. Most R users are downstream from the data development process, not necessarily in all of their work, but in what they use R for their work. So there might be an organization's main database that you connect to, and your job as a data scientist is to pull some data down and analyze it. It's pretty common for people to be in this, and that's pretty straightforward. The other thing that people sometimes use SQL databases for in the R ecosystem as storage or caching, for data packages where you're distributing data, or Shiny apps where you're running something against a database. But all of these tend to coalesce around sort of SQL reading more than writing. And so one of the things is that the SQL reading interfaces and tool set are really well developed. If you're a dplyr user, it doesn't matter where your data backend is. You can use all the verbs you're used to of filtering and mutating and selecting and manipulating, and it's really well developed. Writing into an SQL database is actually a lot less well supported, or has had a lot less development for great ergonomic rapid interaction. So there's the Dbx package, and you can write a whole table or drop a whole table for that. There's something called the Dbx package, which Doltar actually uses internally because it has some important efficiencies for Dolt that lets you better insert or upsert, meaning you can insert a record that will update a record if it has the same key. And the development version of dbplyr is beginning to incorporate this and have verbs and functions for inserting data and appending data and updating and patching things in a way that would be familiar to SQL users, but hasn't been really the case for our users working with SQL databases. So I think this is an area for development within Dolt R and elsewhere to make that sort of, how are we depositing data, how are we changing data, something more straightforward and intuitive. I want to talk about a couple of real world workflows for this and what we're doing with this on my team. So we've been experimenting with it for like 3 or 4 months now as it's been development. There have been a lot of changes even to Dolt in that time. And so we've been fortunate to actually have the team be really helpful and make some changes that we requested. But the core one, which is probably important for a lot of people here, is machine learning application and doing machine learning on a moving target of data. So we have one project that does global veterinary disease forecasting, and it scrapes data from a bunch of veterinary disease monitoring organizations, and that data updates over time. But those organizations have all sorts of different schema and they change over time. So we can't necessarily count on everything working the same day to day. And we always have to update our scrapers, often changing the schema of the database itself. So we have a database in Dolt, and it's updated weekly by a job that we run and on GitHub Actions. And so that GitHub Actions thing will pull down a database and update the versions of that data. And if something goes wrong, we can fork the Dolt database, make changes to the schema and the structure, as well as the scraper logic. And then we merge that back in, and that's how we can sort of keep this chugging along. In the meantime, we're developing these forecasting models. And so the way we develop those forecasting models is we have a model building pipeline, but that model building pipeline always kicks off from a fixed hash in the Dolt system. So if the database is updated, the main sort of model development repo they're working on doesn't do anything. It sticks with the same set of data. And so we're developing that in a GitHub repo, right, against that fixed hash. But the thing we are now sort of adding for this last stage is then there's also a continuous integration check that runs it against the latest data. So you don't have the problem of constant changes to data as you're trying to optimize your model building process, but we run a check to make sure that as new data comes in, it still works. And I just want to comment, my 2 colleagues, Emma Mendelson and Nathan Lehman, who are sort of the leads for this project. Emma doing a lot of sort of that sort of DevOps engineering on the side, and Nathan building the core of the machine learning approach. The other workflow they're developing is for all of our field and lab projects. The bulk of the work at EcoHealth Alliance is people in the forest, trapping animals, taking samples, interviewing people, doing medical anthropology, doing clinical work at different places around the world. So we've increasingly been able to move to digital systems for that data collection. So lots of tablet-based data collection. Where it's not tablet-based data collection, people are entering things into a sort of a live web storage as opposed to things on their own machine. And so they do that using a couple of tools, one called Open Data Kit, one called Airtable that you might be familiar with. And what we're trying to build from this is a system where we take those in, and those continuously populate a Dolt database that updates over time as the field teams change. But that database also has schema changes as we discover new things that we have to record. Often a field database program changes over time because new goals are added, say, to the survey work. We're going to work with more species. We're going to do new tests. We're going to move from PCR-based viral detection to serology to detect viral antibodies. So we need new fields. We're structuring something differently. Maybe those species changes happen. So that database has to change over time. But that database is also the base against which our scientific publications happen. So researchers who are doing work off that database will be writing code to run models from simple regressions to sort of complex phylogenetic modeling, essentially. And they don't want to work with a moving target. And we're sort of separating them from the Dolt workflow by saying, well, if there's a CSV export for everything on Dolt Hub, we start running our analyses with that. So run your analysis, from this URL, you pull down this CSV from this hash, and you can do your analysis. And if you want to update, you can just update to the new branch tip. And when we get to the point of scientific publication and getting things out, where we need sort of a whole package where everything is reproducible, we can tag both our code and our data to create a release, and both together get and both can be archived and linked to each other. And that sort of separates the Dolt process, which is going to be much less familiar to most, essentially because we just have sort of CSV as the interchange between our live data process and the analysis and scientific archiving. So there's a few things that I'm planning to do with Dolt R itself. I want a better interface to the Dolt Hub API as that's being developed, and just to be able to query against the website the way you can query against a local database. It should be able to support spatial data soon. That's more of a MySQL issue. Dolt and MySQL both have native spatial formats, but the R spatial ecosystem hasn't quite caught up to having methods to deal with them. So it's pretty straightforward to put that together, and that's something you can have so you can store your shape files essentially in your Dolt database. Dolt has new versioning functions, so Dolt R needs to wrap those and support them. And then I want to think about some of those database writing economics. Like there's not a straightforward way that's like just add this column to the table in the database, or just add this data that may include new columns to the database. And we are doing some of that in our sort of like in our core workflows, and that will end up migrating to Dolt R, the Dolt R open source package as well. And of course, if you're interested in trying out and want to file issues, just go to our GitHub repository and say what you're interested in. There's also a lot of stuff to come in Dolt itself. It's a very fast-moving company with a very fast-moving development. All of these things that showed up in the past couple of years, all of these things that are showing up this year, a whole bunch of other things that are not scheduled, a bunch of other things that were put in that were not necessarily in the roadmap, which is linked here because users like myself, but other people came in and requested things, and they're very responsive. So if there's something that's a sort of an essential feature to your workflow, it might be something that can come in, and we'll have Zach and Jason talking about that, and you can ask them questions in just a minute. So that's it for me. I'm eager to hear your questions about Dolt R and Dolt, and talk with the developers that we'll invite on.
Everyone, a virtual clap for Noam for that excellent talk. Noam has given, like I said, many talks over the years, and each have been about different topics completely. We've had it about redoc, we've had it about Corona, it was about GAMs, about data versioning. We've had so many different types of talks with Noam. It's really cool seeing all these different talks. Everyone, please, let's have that nice virtual applause. But let's go ahead and do a Q&A.
Let me introduce Zach Musgrave and Jason Fulgum.
Welcome, folks. Everyone, a big round of applause for people joining in the middle.
Right. So Zach and Jason are developers at Dolt Hub, who I've worked with in the past couple of months as I've gotten to know their product. I don't work for them, and I'm not paid to endorse them, and I'm happy to critique Dolt from the perspective of and our user and developer, but it's really been a pleasure working with the Dolt team. They're really responsive and interested in the use cases that people might be putting their work to. So we're eager to hear your questions. Before I guess we get questions from anyone else, I guess I'll have a question for Jason and Zach. What do you think people should know about Dolt and Dolt Hub that I didn't cover?
Good question. I think the biggest one for me, hopefully you can hear me, hopefully audio is working. Wanted to point out one of the new features we launched actually just yesterday. So we've been doing a lot of work to make Dolt better, add a lot of features. You mentioned those. One that we just launched this week that we're really excited about is hosted Dolt. So we heard from a lot of customers that they want to use Dolt, but they don't want to run their own database. So just that's the number one thing I would mention, is that now there's a way to use Dolt and have us manage and run it for you. And you can just use it all you want through the web UI.
Yep. The other thing I would add, I think that Noam touched on this during his talk as well, is that performance has not been our biggest concern up until now, but we are in the middle of a rewrite where we're seeing anywhere from 4 to 10 times speed gains, depending on what kind of read or write we're talking about. So it is getting faster. We hope to be as fast as MySQL kind of by the end of the year. That's kind of I don't think we're going to be as fast as some of the CSV tools that people in the MLOps space are used to using, but it'll definitely be as fast as a traditional database like MySQL or MariaDB.
Jason, you mentioned Dolt hosted. Is that different than Dolt Hub that Noam was showing earlier?
Yeah, that's right. Yeah, so we've had Dolt Hub around for a while. It's really the analog of GitHub, just like Noam mentioned. So you can go there, you can access your databases, you can collaborate, but you don't necessarily get a just direct SQL connection like you do with a traditional database. And we heard a lot of people asking for that. They want that SQL interface for OLTP workflows, which is different than what we provide through Dolt Hub. So if you're writing an application and you wanted to have that traditional database access, like connecting with a MySQL client to a MySQL database, that's exactly what hosted Dolt is. So we're really excited about that. I'll post in a link to our announcement blog as well into the chat.
Yeah, I think for this audience, Dolt Hub is probably the more relevant place. It could, like Jason said, it really is a direct analog to GitHub. It's kind of for this offline collaboration. So you're not using Dolt as a live database that you're going to hook up to an application. You're using it to share data and collaborate with others. If you do want Dolt to power an application, then that's when you'd want it to be hosted.
Or you just don't want to deal with it yourself?
Well, you don't have to deal with it yourself on Dolt Hub either. It's just you can't connect to it with your MySQL client, right?
And that actually brings me up to a question I had. Noam, please want you to ask a lot of these, but this brought to it. When you did Dolt clone, Noam, does that pull down the entire database from Dolt Hub to your local database? What's going on there?
Yes, it's sort of much like when you do a Git clone, right? You are pulling down not just the files at the tip of the branch, but the whole history. And so Dolt clone does the same. You're pulling down the entire database, including all the version history. So it's going to be larger than just the tip, but through sort of the efficiency of the storage, it's not like you have every version that's there. I don't think there is a shallow clone capability. You can clone into a new database in a sense that like you can create something fresh from the tip, if I recall, and you might even be able to do that table by table. But there's no sort of shallow clone of the sort that you have with Git clone.
That's not quite true. There are some kind of hacky ways to get a shallow clone. They're not well supported, so we don't talk about them very much. But we know this is something people have asked for, so we're working on ways to kind of expose these and make them better. We also kind of envision a future where most people, when they run a clone, if it's on a large database, you're not going to be pulling down every single byte from the remote store. You're only going to be pulling some subset that you need to get started, and then you'll do a mix of reads and writes to local disk and to remote as needed. So you can kind of run it as like an internet-enabled application if you want to. And this is just to make clone lighter weight.
And Noam, you just sort of touched on this question, but the question is here. Does storing all these diffs take up a lot more space than just the data itself? And you touched on it, but does anyone want to dig in deeper, some quantification?
Yeah, I can fill this. So the Dolt is not delta encoded in a technical sense, but you can kind of think about it in terms of its storage costs in terms of delta encoding, right? So if you and I make some tables, and then we make some commits, and we add rows, and we make another commit, the proportional cost of those later commits is the delta between the two versions of the table, right? You're not, this isn't quite true. There's technical details to go into, but that's the right way to think about it. So you're paying storage costs proportional to the amount of things that change between revisions, and then multiply that out for all the revisions in the database. But it is like Git, it is snapshot encoding at its root. So it has the nice property where if I make a bunch of changes and then undo them, I'm not paying a double storage cost for the things I undid. I'm not paying to delta encode it and then paying twice to undelta encode it. If I have two table snapshots that have the same data, they actually are the same snapshot. So I don't pay any storage penalty for storing that version of the table twice. That's a nice property.
So let's say you have a table, 100 rows, you add a row, you're now storing that 101st row and a line saying that that 101st row is new.
Yeah, it's again, there's technical details and there's going to be some overhead for that, but you have the right idea. It's proportional to the size of each change as opposed to storing each snapshot as a whole.
Yep. All right. And then if you have the 101st row and you change it, you're now storing the changed one and the diff about the changed one, roughly.
That's exactly right. So Dolt treats modify as kind of a delete and add. So for every row in the table, we have the old state and the new state. It's not smart enough to kind of like if you have really wide columns or really wide rows with say hundreds of columns, which can happen in NL. It's not currently smart enough to, if you only change one of those columns, you're only going to change, the 10 bytes in the storage format. It's gonna make it an entire another copy of that whole row. So it is the row is kind of the unit of diffing and versioning in Dolt.
Okay. Noam, before I go through the rest of the audience questions, do you want to sort of ask as a
No, I think we should jump into some of the ones and even expand on ones that were even added in the chat. So
okay.
I see one from Eric Scott. Hi, Eric. Eric asked if we run the Dolt status, what does it look like if we just change a single value in the table? So I run it, it doesn't change anything different. So Dolt status, if you run git status, right, you get the list of the files that have changed. And then depending on what your like sort of view preferences are, you might get like the number of line changes or, number of lines deleted or not. Right now, Dolt status in R, and remember this is the R API wrapping different parts of the Dolt internal API, just will tell you if the list of tables and whether they've been modified, added, deleted, whether you add one line or add 100 lines, it's going to tell you modified. One of the things that I'm sort of been thinking about is like, what should sort of like the default diff view be? Dolt has a whole number of system tables and an increasing number of functions that are designed to like give you a view on diffs, right? And there are different things you want in those diffs, including like just the changes that are the schema changes, right? Like just like what columns have been added or what tables have been added, as opposed to like what values have been changed. And so probably want to have, I currently don't have like the default, here's the changes, which is sort of the equivalent of like when you go to the diff button, right, in Rstudio, it'll show you, here's the, you can click on the file and here's the green parts that have changed and the red parts that are gone. Currently in R, you don't get that. And so you have to do a slightly more elaborate query of those diff tables to get the specific differences.
Yeah, the Git tool or the Dolt tool itself hopefully picked up on this. It works exactly like the Git command line. So all the commands that you're used to in Git, they work exactly the same. They take all the same arguments, the same flags and everything. So there's a Dolt diff command, just like there's a Git diff command, and that's going to show you the red and green plus and minus for every row that you change in the table. And it also has a -- summary flag you can give it. So if you have a large set of table changes, you just want to make sure if it do a sanity check on it, it'll show you how many rows have been added, how many deleted, how many changed, etc.
Cool. So now all those Git commands can actually be very, very confusing, a lot of them. So hopefully we'll have an easier time with yours, because I know I have my go-to, one of the conference speakers, Dan Jin, he's my go-to, hey, Dan, I screwed something up. How do I fix this thing? Hopefully I won't screw as much stuff up with this.
What's really cool about that, and I run into this too, everyone has these problems with Git because Git's such a confusing tool. When you Google the help for a Git command that you're confused about but it's the Dolt equivalent, you can usually take that Stack Overflow answer and apply it directly to the Dolt command, and it works. Because we've taken pains to try to make it familiar to people and to work exactly the same, because Git's confusing enough without trying to add anything on top of it, right?
And a point to make is that I mean the R package is a little behind the command line client in doing that. And part of it is that it's not quite the same one-to-one because I'm trying to merge these two interfaces that R has. There's a standard interface with the database, and there's a standard interface with Git. And like there are places where those begin to crash into each other. And that's where it ends up being a little bit different. So like the checkouts end up being a little different because in Dolt, there's sort of different ways that you can check out a branch, but one of them is use. And use is a database command in MySQL, which says like which schema to go to. In Dolt, it's which commit to go to. And it's one of those things that like, you know, I've created something that's a little different than the Dolt command line because it seemed like the natural approach in the R context. So for that, you just have to bug me in the Dolt R issues.
A question just came in, so why don't we do that before we do the other ones? Because I can't copy and paste out of Zoom to save it for later. So since it just came in, Noam, you want to run with this latest one?
Sure. Let's see. So Patrick asks, I work in a humanitarian setting where administrative data is often stored in Excel. Often I don't have control over the management. So I have to work with what I get, even if types of columns change. If I import new version of some table into Dolt, does Dolt auto infer schema changes as well as record changes, or do you better create a new table with this new revision? So I'll start on this in that like, this is what, well, auto inferences, I guess you led to. Like one of the great things about Dolt is like schema changes are core to it compared to a lot of other versioning systems where you're like, we're stuck in a schema, we're just changing records, right? Like temporal tables do that. You know, Dolt is all about the schema changes, right? And having efficiency through that. And that's why it works for us. Dolt has an import CSV command. Which is sort of the standard way to get things in the command line often. Again, within R, it's a different thing. You add a data frame. In R, if you were to drop a table and add the table, actually, Nathan, who is on there, would actually keeps telling me because he's like, this is the efficient way to do this because Dolt pretty much infers the thing. If you just drop a table and then add a new version in that has different columns, right? And then you commit, Dolt will pick that up as a change to the table with these new columns added and these types changed and these other, and you probably get better type matching than you might with a CSV import because R at least has types that match up to your SQL types. Anything to add to that?
I think that's a great summary. This is an important point, is that because Dolt is snapshot based and it does diffs on snapshot, dropping the table and then just re-importing it from scratch is exactly the same structurally as changing the table and making all the edits. And it's usually a lot easier to just drop it and import it from scratch in the use case you're talking about where somebody's shipped you in a version of the file. The only thing I'll add is that the import CSV command does some sort of type inference for you, but it's not a perfect science. It gets things wrong sometimes, especially depending on how your data is formatted in Excel. So for that case, what I would recommend is drop the table, use a SQL create table statement to create the whatever types you want for your columns, and then run the import command. So establish your schema first with SQL, because you might get better results for some sets of data than you would by letting it infer it automatically. Anything to add, Jason?
I think just that this is such a cool use case for Dolt. It'd be awesome if your data partners use Dolt and you had all the data, but just because they don't doesn't mean that you can't get a lot of value out of Dolt. And we see a lot of customers using this use case.
Yeah, that's an excellent point. Is one of the things that we hear from customers with this use case is that I don't control this file. It gets updated out from underneath me all the time. I want to understand how it's changing over time. And so they're not using Dolt to master the data. They're using Dolt to kind of understand how this external source is changing over time, and so they can make sense of it. That's one of the best use cases for Dolt.
I think maybe one more question, Jared.
If you folks have time, we can keep going for a little bit because we do have a few more. I have a few more toiled away. Okay. One that just came in, again, we're going to do the most recent ones first so they can't copy and paste. The gist of it is, can you add users to the private repo like you can in GitHub? And what is counted toward the gigabytes in the free tier? Does it include the metadata?
I'll give that to you guys.
Yeah, so Dolt has basically the same permission model as GitHub. So you're going to pay. You don't have to pay within the free tier. After you hit your 1 gig storage limit, then you start getting charged $50 a month. But with those, if you sign up for private, then you can add as many other collaborators to your organization as you want, and they can all see your data, and you can control who has read and write access to which of your databases that you host on Dolt. The storage cap of 1 gigabyte is everything. So your history of your database and everything that's ever been in it applies to that 1 gig. If that's too low, this is not the primary way that our company makes money. $50 a month for Dolt is not material to us at this point. We're selling OLTP licenses and support contracts to make money at this point. So if that's kind of untenable for you and you're a researcher and you can't handle the $50 bill, just come join our Discord and talk to us. We have coupon codes that we can give out. We're very comfortable supporting you up to 10, 20 times that amount, as long as we think your use case is cool.
Some older questions in here. How did you decide between MySQL and Postgres? What made you go with MySQL versus Postgres or any other open database, actually?
So yeah, this is my fault. So as everyone knows, Postgres is the better database, but MySQL is the more popular database. And so when looking around our database options, we kind of decided to meet customers where they currently live. We definitely see Postgres as having more momentum, and it kind of is more serious for people building applications. But especially at the time we developed the SQL integration with Dolt, which started out as a command line tool without any SQL support. For us, the biggest thing was just the amount of people using the tool. We like MySQL. I built a lot of apps on MySQL myself, but we're definitely in the future going to build towards Postgres as well. There's a project kind of in its infancy that we're calling Doltgress, which is basically just a Dolt flavored version, or a Postgres flavored version of Dolt. That's not going to be ready for at least a year, but we do know that people want this. And when that's available, you'll be able to just kind of toggle a switch on hosted Dolt to get whichever flavor of the database you want.
Cool. Let's see.
It's interesting on that, because Postgres is much more popular, I think, in the R tooling space. On a number of fronts. And so it's interesting because there are a number of things like the spatial data, for instance, where I'm like, am I going to build the so the R spatial system just like doesn't have the MySQL and MariaDB spatial types as part of it. Like it's not a huge. Michael Sumner is here. He's one of the big developers in that ecosystem. It's essentially well-known binaries with slightly different metadata than the other well-known binaries. But like maybe I'll build out that spatial, or maybe I'll just wait for the Postgres one. We have sort of spatial as well as like how to handle rasters as structured binary blobs in that as well. So I'll be interested to see how that comes along and where we decide to invest build the R connectors off of.
Cool.
Yeah, there's and we had a few talks about spatial. We have a few more talks about spatial coming up. So everyone wants more spatial in some way or another. Yep.
Yeah, it's one of the last kind of gaps in coverage for our basic functionality with MySQL. So we recently added support for spatial types. It's new as of I think 3 or 4 months ago. The limitation right now is you can't, there's like 100 spatial functions in MySQL, and we only support 20% of them right now, just the ones people have asked for. And 2, you can't create indexes on them, which I'm not sure if that matters for the data science crowd as much as it does for the SQL application crowd. That's definitely what our customers are bugging us for, but it's a challenge. Indexing spatial types is different from indexing integers, and there's a lot more to go into it.
From what I can understand, the indexes are very important because it could dramatically cut down, like ST intersects. It can dramatically cut down the time to compute that if there's a spatial index.
Yeah, makes sense.
Or R trees. And speaking of indexes, I think you answered the question, can we have indexes in the database?
Yeah, absolutely. I think Noam is probably better positioned to answer how that would impact your the R use case. I could like for a SQL query, it's definitely going to use indexes to make your joins faster and to make point lookups and range selects faster. But I think Noam has probably more advice about how those flags
It's
are.
interesting because this really gets at sort of like where the R analyst versus sort of like the whole sort of data science ecosystem is. So like there are those of us, some of what I do, Michael's in the audience, are like, you know, building systems that are ingesting things and then providing data sources for researchers, right? And you know, we often want to think about, okay, how are we going to, you know, how are we going to store? How are we going to create indexes? How are we going to make things maximally accessible? I think for a lot of people who are sort of on smaller projects and building up, it's not like most of us who are doing that, like we're working in the native, like I'll be writing SQL to do that essentially, right? Mm-hmm. And then you'll have readers, but also I think more people who are just like building, you know, building up collaborative data stores and stuff like that. You know, they're only doing so much in terms of just like getting, you know, like keys across the database and things like that. And I don't know, you know, this audience changes all of the time here. So I'm not sure, but I think it's not necessarily going to be the highest priority thing. Having the spatial index it's just that, right? If we're going to distribute a bunch of data, right, being able to do those lookups is going to be pretty important.
A question came in about how do you deal with merge conflicts?
You want to tackle that, Jason?
Yeah. So like we talked about before, there are really two main interfaces for working with your Dolt databases. One of them is the SQL interface, and one of them is the CLI. So you can merge and you can deal with conflicts from either of those interfaces. If you're working with the CLI, it's going to be pretty much just the same experience as you're working with the Git CLI. You're going to merge a table maybe from another branch, and then Dolt will tell you if you have any conflicts. And then to resolve those conflicts, you can use the CLI and you can select your changes or their changes. So you have some simple options for conflict resolution. Zach, of course, jump in if I'm missing any big points. But that's kind of the CLI experience. In the SQL experience, you have a little bit more control. So for example, you might start your merge from the CLI and see that you have conflicts, and then go into SQL because you want to do a very fine-tooth way of resolving that conflict. So I would say that's probably the main way that people will resolve conflicts, is using the CLI to do the merge, finding out what conflicts exist, and jumping into a SQL interface and just resolving the conflicts in the table itself, marking those conflicts as resolved, and then committing. So really kind of the same workflow as Git, except you're kind of jumping into SQL to very directly modify the data as part of the conflict resolution.
When you say jumping into SQL, like it's like a select statement or an update statement or something?
Exactly, yeah. So you open maybe a SQL shell or your favorite SQL workbench, and you can look at the data and see the two versions. You can see the conflicts. There's some system tables where Dolt will tell you exactly where the conflicts are. And then you can just work with the data however you want it to be. And when you're done, just tell Dolt that you've resolved the conflict manually and that you're ready to commit the merge.
Yeah. And this is a place where, like, you know, like the R ecosystem doesn't have this language spelled out in its own way. And maybe that's the best way. It's like you end up dropping in and sending a SQL command through your R console, which is what you can do with like a DB execute or a DB query command, right? So unlike sort of the dplyr stuff where essentially like all these R commands are translated into SQL in order to perform really complex queries that extract data, there's no real equivalent to sort of modifying the data in the database. And so it'll really be, I don't think we're going to build out that whole grammar for this purpose in Dolt R. So it will be sort of that dropping in, but I think having a little more so that it spits out the conflict table that is generated so you can see it will be something that can get developed in the Dolt R client.
Yeah, to elaborate a little bit on what Jason and Noam said, when you have a conflict in a file in Git, the way it represents that is you have these conflict markers where it shows here's what was in the head, here's what's in yours, here's what's in theirs. And Dolt does something very similar, except instead of files, obviously it's tables. So for every user table, you have a table named foo, and that table has conflicts after a merge. There will be a system table called foo conflicts. And that table has a schema that's derived from the user table, and it'll show you for each line, for each row that's in conflict, the base value, our value, and their value. And the way you resolve these things is by doing select and update statements with joining with the conflicts, where you can get arbitrarily complex because it's just SQL. And then you tell Dolt that the conflicts are resolved by deleting rows from that conflicts table as you resolve them. And then when the table's empty, we consider the conflicts resolved. You told us it's just like deleting the conflict markers in your text file, and you go ahead and make the commit.
So selfishly, is there like a VS Code version of this? I know VS Code, you can set accept head, accept incoming. Do you have something like that coming down the line, a VS Code plugin?
I don't think so. At least not anytime soon. We do work. If you have VS Code and that's your jam, you can just kind of use the MySQL connector for that and just pretend that Dolt is MySQL. And that's true of any database workbench that you might have. There might be some compatibility issues we're still working on. So if you find one that doesn't work, tell us. But in general, yeah, just pretend that it's MySQL and connect to it with that, and it should mostly work.
Cool. 2 questions came in. I'm going to do the second one. Seems more relevant to what you're just asking is, do I need to know SQL to use dolthub/doltar?
So let me start on this one, because sort of the point of doltar to a certain extent is to make it so you don't, right? There are definitely limitations to that, like the ones we just discussed, because sort of editing data is something that R supports less in its sort of like, it's all machinery that hides SQL. But for a few things you don't anymore. So like one thing that I came in and I started using Dolt Hub, and then I like put in an issue request immediately, and I was like, hey, could we have just CSV exports of everything, right? Because like I want to, seems like a great place to put data, but everyone needs to know SQL and know Dolt in order to get that data. So now, right, if you're using Dolt Hub or someone else is using Dolt Hub and you just want to work off the database, including any sort of, any commit, any branch, you can sort of read your CSV straight from Dolt Hub, right? And that's one of the workflows that we're setting up. That's how our researchers are going to end up using this, because they don't need to learn that, right? Then this, where R interfaces with SQL, the DBI and the DB plier packages, you can add a whole table, you can read a whole table, you can run your a filter and a select and a group function in order to filter and run to generate, and that internally generates SQL, and that pulls the data out. And I think one of the interesting things that we sort of might develop, just like even in the vignette, is how you do the versioning part of that. So like, so that you're pulling your table, but you're pulling it as of this commit, or you're querying the table history using that domain-specific language as opposed to SQL. That's something you'd be able to do, right? Again, where the real challenge ends up being is in editing data directly beyond the appending a bunch of records, dropping and adding a table, and a few other of those components. But I think, it's something, so like we have some long and weird functions that we've written in our internal pipelines that we want to migrate, right? That do things like modify column types for new data, right? Like, so like you're adding you're adding text that is longer than the defined fixed width of the text field. It detects that, and then it changes and it extends the width of the text field to allow for more data than it was previously there. So like that's something that we have built up and we'll put into the open source package soon enough. So the answer is not entirely, right? That there are probably limitations, and that's when you have to dive in. But that's the case working with any of the SQL databases in R, not just Dolt.
Yeah, I think that's probably the right answer. Is ideally no, but there's a chance you're going to end up with some. Depending on what you're doing with Dolt, you may need to learn a little SQL. I think that the best way to discover what the limits are is just to kind of start playing with it yourself. Dolt Hub will let you just upload CSV files and turn those into tables. And that's kind of a great way to start playing with Dolt, just to discover what the capabilities are. You can do a lot of stuff just from the web without having to deal with any SQL or any files or anything like that. We do have people who use Dolt kind of SQL free, I would say, where they're really just importing CSV files and they have a new version of it and they scrub the table and import the new version and make a commit because they're, again, just wanting to see what changed over time and keep that as the backup record. That's certainly possible. It is a little bit limiting, and I don't, like Noam said, I don't think it's going to play that well with, if you want to use this with R, but as a command line tool, you don't strictly have to know any SQL. It helps, but you don't need to get started.
Just to give another concrete example, we have one customer I was talking to where they really enjoy the kind of spreadsheet editor view on Dolt Hub, and they want to have their configuration for their system versioned. So a great fit for Dolt Hub, or for Dolt, to version that data, and then they want to enable these less technical people who set some of those configuration values to go through Dolt Hub and send pull request. So they're definitely still using Dolt, they're using Dolt Hub, but they're not necessarily using SQL. So I think just like Zach and Noam described, you can certainly use it without SQL, but there's a lot of features in there. Some of those are going to need to be exercised through SQL.
Great. I know we're starting to run a little late, so I'll just get just a couple more. Can Dolt dump, one of the functions Noam showed earlier, export just one table, even just parts of a table?
Now I'm trying to remember how I did that. Let's see.
You want me to talk on this now?
My implementation just drops. My implementation exports everything. I don't remember if Dolt's dump in the command line gives you can select a table for it, right? I'm sure I could write in a slightly extended version because it's just, it's doing the select function and then running the export would be fine. Right now the R function Dolt dump just dumps everything in whatever format is being dropped.
Okay.
Yeah, so on the command line, you could run Dolt dump and give it a list of tables to just restrict it to a set of the tables that you want. If you want only parts of a table, you can run a query. So, select star from my table where index greater than 10 and output that to a format of your choice too. You take a bunch of format flags like CSV or JSON or whatever you want. That's what we'd recommend for that use case.
Okay. When you export a CSV, is there any metadata that traces it back to a specific commit?
There's not. I don't think that there is a great way to represent that with CSV. That's an interesting use case, though.
I think there is an obscure format of CSV where you can actually put comments in it.
Yeah,
Right?
the CSV-Y has YAML at the top, but I think what I think might be more relevant here is if you're pulling a CSV from Dolt Hub, just you're grabbing the URL, then you can just as easily hit a Dolt Hub API point, right? And so there are API endpoints for each of the tables in your Dolt Hub database, and so if you just hit the API for your table, it gives you the schema for that table, and then you can add a query and you can get data from that as well. And so this part that's in my to come is that I wanted to build out the Dolt Hub API client within Dolt R. One of the ideas for that is essentially you can use Dolt Hub and just query it directly, and it'll pull that down, right? And then also use that schema information to set the types correctly in R when you pull that data from the API. So if that's the information you're looking for, and I'm pretty sure, that REST response also gives it the reference in the database, be it the branch or the commit that you're pulling from as well. So the standard CSV endpoint doesn't, but the standard REST endpoint that gives you JSON does. And
then just two more, one Dolt question, one Noam question. on Dolt Hub/lab, is it possible to control access at the table level? And I will augment that on the row or column level also.
Not yet. If that's something you need, please join our Discord and talk to us about it. Dolt Lab is 0.3 right now. So we're very early on that journey. So we'd love to hear more about your use case.
Cool. Okay, and then lastly, all right, sorry, just this quick one. No, when you were doing Dolt, the function Dolt, can you say that to an object like you can have any other DBI connection? This way you can say like con gets Dolt all the information.
Yes, definitely. You run that con gets Dolt, that works just fine. And like there are standard DBI functions in there too. So there's one called Dolt local. It says connect to any other local directory where there's a Dolt database. There's Dolt remote, connect to any other URL or localhost port where there's a database. So you can do those as well under DB connect, and then you can save that Dolt. It's just a standard DBI connection object. But what's special about the function is that it also is managing this. Like when you run it, what it actually does is it stores that connection in an internal cache, and then so instead of reconnecting, it pulls from that and checks its validity. And if it's not valid because the server has stopped for some reason, then it will reconnect, right? It will restart the server if it needs to, or find the PID of the server and get it back. So, I've just come to just using Dolt for, set that environment variable, and you don't have to think about that background process at all. It's worked a lot better than I actually thought it would initially, but
Yes.
It's helpful. Yeah.
Great. And then I did promise a Noam question. When they renamed the Flying Fox, was that because they found a bigger one?
No, they did not. But it was like many of these, it was that they figured out that what was previously thought as two different species were one. So one, and generally that means that the one that was identified earlier, right? So like someone called something medius and someone called something gigantus, and eventually I think they figured out that the gigantus ones were really just the same as the mediuses. I'm pretty sure that's what happened. And so maybe one day. It was only like a year and a half ago, they discovered this amazing like new large orange bat in the Philippines. Really was surprising. So there are still perhaps bigger bats to be found somewhere. They're not all counted yet. So maybe there'll be a gigantus or mega gigantus somewhere hiding out.
We can only hope.
Yeah, right. And then we'll update all of our tables, of course.
Yes, again. All right, well, great. Thank you very much to Noam, Jason, and Zach. Hope everyone had a great time. Remember that we have June 2nd, we have both in-person and virtual meetup with David Robinson. We have June 8th through 10th, the New York R Conference, both virtual and in person, a whole bunch of speakers and workshops. If you're here today, you get the code NYHackR30. Remember, you have your no starch discount with code IRNY22. And go ahead and ask on our Slack. We have our monthly meetup chat. We also have channels for help with R, with Python, for Git. I don't know if we have a SQL channel. We should create one if we don't have one. And hope to see everyone at our next events, either in person or virtually. So everyone just please, a virtual applause for Zach, Jason, and Noam for this excellent talk. Thank you, everybody.
Thanks, guys, for joining.
Thank you.
Thank you.
Bye-bye.
Have a great night.
Bye-bye.